Now, we can still see our cubic equation on the board. ax cubed plus bx squared plus cx plus d is equal to 0. Before we can use this equation, then it means that we must transform the cubic equation into the form x cubed plus ax plus b is equal to 0, where we have our a, and then b, after which we can substitute them into the equation. But how do we do that? Well, targalia, first of all, reduced the cubic equation into this form. So check it out. You realize that he has reduced his coefficient to the x cubed into 1. For that matter, we no longer have ax cubed, but rather only x cubed. And then ax squared, bx, c, and then 0. Very good. Yet, we wanted to have this equation x cubed plus ax plus b is equal to 0 in order to have our a and b. How do we do that? He said, in order to transform our cubic function into this form, that is equation 2, then all what we have to do is to get this transformation equation. That is, x is equal to y minus a out of 3. By this method, we will be able to get our equation 2 by substituting this one into our equation 1. Let's have an example. Now, this is a cubic equation. According to targalia, the first thing we need to do is to reduce the coefficient of the x cubed into 1. That is, yes, by dividing through by 2, we have been able to reduce the coefficient of x cubed into 1. Beautiful. Now, our next step here is to substitute this equation into that. Alright. Now, again, take note. Comparing this equation and that of equation 1. We have x cubed, we have negative 3x squared, and here we have ax squared, which means that our a is the negative 3. So, in using this equation, instead of a, we're going to use negative 3. Take note of that. With a simple analysis I was doing with you, let me do the solution here, where a is equal to negative 3. Now we have got x, that is, x is equal to y plus 1. Let's now do our substitution. Now, we need to expand this one, y plus 1 all to the power 3. And using Pascal's triangle, we can say that we will be using that of 1, 3, 3, 1. Can you take note of equation 2? We shall be coming back to that equation. Alright, now let's continue with our expansion. Okay. Grouping like terms. We have y cubed plus 3y squared. We have another 3y squared that is negative. Also, we have y. We have negative 6y. We have plus 2y. We also have 1. And then plus 1 plus 5 gives us 0. Okay. Now, the 3y squared takes away this 3y squared, that is positive and negative, giving us y cubed. And then, now, this y and then 2y gives us 3y. If you should subtract this 3y from this 6y, it means you're going to have negative 3y. And then 1 plus 1 plus 5 gives us to this part. We can compare this equation to that of equation 2 as if you take note of. So, by comparison, we can say we have y cubed, that is s cubed, negative 3y, that is ax, which means that our a is equal to negative 3, and our b, that is 5. B is 7. Yes, now we have got our A and then our B. So all we need to do is to substitute these numbers into the equation. And once we substitute them into the equation, we are going to have one of the roots of a cubic equation. Yes, this is how far I can bring this lesson to its successful end. In my next presentation, I'll be explaining to you how we can use this equation in finding the root, and in general, how to solve and get the root, I mean the solutions to a cubic equation. Thank you.